Good afternoon, everyone. I'd like to invite you to our talk on securely deploying MongoDB Atlas clusters using infrastructure as code, the Liberty Mutual story. My name is Brian Poirier, and I'm here with Brian Jones.
Hey, Brian. Thanks for introducing us. I'm really excited to tell everybody about the progress we've made over the last year or so with all the Atlas features that we've been implementing. But I think we need to practice social distancing. I think we're a little too close for comfort these days. So, this is way better.
There we go. Good afternoon. For today's presentation, we would like to talk about our Atlas journey, specifically items we work with MongoDB on to automate some Atlas features through pipeline code. Once we go through the presentation, the other Brian will show a demo highlighting some of these features. And after the demo, we'll look at some of the projects that are still in work. In an effort to help customers pay for what you need, Liberty Mutual depends on modern technologies to provide fast, accurate insurance information to our customers and partners. At the heart of these complex systems is the modern database, specifically a highly distributed, reliable, and scalable database that adjusts to the ever-expanding world of enterprise information systems. These are highly complex systems, and as members of Liberty Mutual's hosting services, it is our job to bring these technologies to our customers in a secure way that is fully compliant and compatible with our current systems. For Liberty Mutual to use Atlas, there were some things we needed. And this is the story of how we approach and work with MongoDB to successfully implement some of these features into Atlas. First, we would like to walk through our current Mongo operating environments. Mongo is a popular service within the Liberty Mutual developer community, as our on-prem environment currently consists of over 700 replica sets. Once a replica set is created, we provide all the monitoring, management, backups, and lifecycle maintenance for non-prod and prod environments for our customers. Replica sets are standard 3-member nodes with some larger replica sets used for top-tier applications, but these are non-standard setups in which we have to configure manually. This all adds up to a lot of support work. Though all the resources are created and provisioned through automation, maintenance tasks such as user management and database upgrades are manual processes, meaning we have to provide lower levels of support. Also, we never designed the replica sets to handle advanced features such as sharding. Since sharding offers a great way to scale out, I refer to this as being horizontally challenged. Indeed, we have a sharding gap. The on-prem environment also presents other challenges. One of the greatest features of continuous integration and continuous delivery, or CI/CD, is in automating tasks such as upgrades. Our on-prem environment consists of some 3.4 and below Mongo replica sets. This represents our technical debt, and without an automated process to handle upgrades, technical debt monsters become old and fidgety and have a habit of calling DBAs at 3 a.m. on a Saturday because they need special attention. Without a pipeline-driven process, these monsters tend to multiply as time goes on. Continuing on our journey, we look to the cloud to save us from the technical debt monsters. As Liberty Mutual expanded into cloud computing, so too has our MongoDB service offerings. With applications now being fully provisioned through CI/CD pipelines run on cloud platforms, so too are our Mongo EC2-based replica sets. Built on Community Edition MongoDB, we can now offer our customers a fully integrated and automated MongoDB environment with EBS-based encryption and security with all additional AWS features. This new environment has been a game changer for our customers, as automation and integration is something our customers have insisted on. Since these builds are on Amazon AWS, we now have the ability to leverage AWS's services, including CloudFormation templates, or CFTs. CFTs provide the ability to configure all database parameters through code and are compatible with our in-house automation platforms. Currently, our team supports the CFT and Amazon Machine Images, or AMIs, needed to provision these instances. Additionally, user maintenance is managed by HashiCorp Vault, but more on Vault in a moment. One significant drawback to Mongo and EC2 is the fact that EC2 is a service provided by only one cloud provider, in this case AWS. Though a fantastic cloud platform, we understand that AWS does not meet the needs of all our customers' use cases. Luckily, we don't have to build native solutions for all major service providers, as MongoDB Atlas fills that checkbox, expanding our service portfolio to all three major cloud vendors. Since Atlas arrived on the scene over 2 years ago, Mongo has added many new features that have greatly expanded the product's global reach. Incorporating many advanced features such as sharding, we are now able to fill our sharding gap. We're no longer horizontally challenged, and we have found Atlas to be fully capable and have come to appreciate the full-featured services that MongoDB has put into Atlas. Currently, Atlas meets industry security certifications such as HIPAA or ISPO 2701 or GDPR and PCI SOC 2, which has made Atlas an immediate competitor to our on-prem and EC2 Mongo offerings. Also, one greatly appreciated feature is the ability to run on all three cloud providers without massive code changes to our repositories. Having the ability to run on more than one cloud provider, as well as on-prem, MongoDB has truly made Mongo a run wherever you want database. This ability to run in multiple places prevents vendor lock-in and allows our application teams to build in whatever environment they need. With an interface similar to Ops Manager, Atlas incorporates many of the familiar tools found within our on-prem environment. However, being a large enterprise with the possibility of rapid adoption among our customers, we need to be able to plug Atlas into our current CI/CD pipelines. We were able to meet with many Atlas development teams through Mongo Professional Service and bring our ideas to the Atlas ecosystem. And today I'm happy to report that many of these features have now been incorporated. And now we'd like to look at some of these features. At this point in the presentation, we would like to transition from talking about our on-prem and EC2 instances and talk more about some of the features we partnered with MongoDB on to integrate into Atlas. As mentioned earlier, Atlas has an intuitive interface and API calls that compare with on-prem Mongo Ops Manager. However, as well designed that interface is, we do not have the capacity to dedicate DBAs to sit in front of the console all day and manage Atlas. We want development teams to be able to deploy and manage Atlas through our existing pipelines, like we have done with our Mongo on EC2. But we do not want app teams to wait while these same processes are done manually, like in our on-prem Mongo offering. And now we'd like to dive into some of what these plugins are. We would like to start with HashiCorp Terraform. HashiCorp defines Terraform as a tool for building, changing, and versioning infrastructure safely and efficiently. And used throughout industry, Terraform is a product that fits within the realm of infrastructure as code. This extremely versatile product has the ability to automate infrastructure deployments and is widely used within the Liberty Mutual existing pipelines. Additionally, Terraform allows teams to standardize deployments, ensuring consistency across multiple platforms and cloud providers. Terraform is a key component for pipeline integration, and thankfully, we're able to work with Melissa Plunkett, Senior Product Manager for Cloud, and Eric Reed, a Senior Consulting Engineer for MongoDB Professional Services. Working with Melissa and Eric, we were able to have Terraform officially supported by Atlas and HashiCorp, resulting in the MongoDB Atlas provider. Connections to the database are another infrastructure item we needed to automate. Unfortunately, existing Atlas tools like VPC peering are not allowed by our security team. Down but not out, we next looked at automating company firewall rules through an in-house development project, but realized that the time to get this in place was too excessive. Instead, our firewall team recommended using private endpoints. The problem was, Atlas did not support private endpoints at this time. Private endpoints, more commonly known as private links in AWS, allow customer virtual private clouds, or VPCs, to connect to other trusted VPCs in AWS. The connections are secure, and that data can only initiate from consumer to provider and not the other way, effectively making the connection one way. Private links have existed in AWS for some time, and we reached out to Mongo to explore the possibility of Atlas supporting this needed feature. Again, working with MongoDB Professional Services, we were able to influence the Atlas team to incorporate private links into Atlas. Additionally, the Terraform Atlas provider supports creating private links, which means that we can now set up endpoints through automated provisioning. With CI/CD pipelines, there is a requirement for zero human touch throughout the provisioning process. However, in order for Atlas to operate with tools such as Terraform, a credential needs to be provided with the correct level of access in order to perform the task. Though API keys have been available in Atlas for quite some time, previous implementations required API keys to be associated with a human user account in Atlas. Because we want zero human touch in our Atlas organizations, we needed a way to separate API keys from humans. That requirement led to programmatic API keys as the solution. These API keys are used in the pipeline so that it can connect to Atlas and perform specified tasks. The keys consist of two parts, a public and a private key. And additionally, keys cannot be used to log into the Atlas console, and they can only belong to one organization, but they may be granted access to projects within the organization. When the key is created, it can be granted roles the same as users, allowing verification that the key can call on endpoints without errors. Keys can also be whitelisted to specific CIDR ranges and IP addresses to prevent unauthorized access. Programmatic API keys are a necessary component of automating pipeline builds. With a key at the organization level, project keys can be created that are attached to only one project, effectively limiting the scope of the API keys. There are many applications available that can manage secrets, including offerings specific to each cloud provider. In order to preserve Liberty Mutual's cloud-agnostic approach to database design, HashiCorp Vault was the application chosen to manage the majority of application and database secrets. Using Vault, credentials have access to database resources based on defined roles that are set up within the secrets engines. Vault manages secrets dynamically and enforces access to secrets and systems based on trusted sources of application and user identity. Though human interaction with the database is frowned upon, there are times when DBAs need access to the database for support operations. In those cases, a DBA can log in and effectively break glass to gain access in order to resolve a specific issue. If the environment is in production, break glass must be accompanied by an incident number, or else the access will not be allowed. Vault was successfully implemented with our EC2 Mongo offering. However, there was a problem using it with Atlas. Vault did not support an Atlas integration. Alexei Menshikov, a senior consulting engineer with MongoDB Professional Service, was able to help us solve this problem. HashiCorp has an extensive developer network, and we were able to locate an open source project that allowed Vault to integrate with Mongo Atlas. During our development working sessions, we were able to get a Vault plugin to work effectively with Atlas. And this was the starting point. Once we proved the benefits of using this application, MongoDB and HashiCorp formally announced that the MongoDB Atlas Secrets engine will be officially supported and integrated into Atlas. As an additional security level, we need to be able to use our own AWS key management system, or KMS keys, with our Atlas clusters. For this service to work, Atlas uses the AWS Customer Managed Key, or CMK, within the KMS service to encrypt and decrypt MongoDB master keys. These keys are used to encrypt and decrypt database files and backup snapshots. When using our own KMS keys from AWS, Atlas automatically rotates master keys every 90 days without the need to have data files rewritten. Essentially, data is encrypted using our own AWS CMK that we manage prior to the data being encrypted a second time when written to the MongoDB encrypted storage engine. You have the ability to use your keys from the three major cloud providers: AWS, Azure, and Google Cloud. Thank you for listening to the presentation. And now for the moment we've been waiting for, the demo. Take it away, Mr. Jones.
Thanks, Brian. I'm really excited to show everyone what we're doing at Liberty Mutual with all the new features that Mongo's released over the last year or so. But first, I want to give everybody some background of the way we do things at Liberty Mutual. At Liberty Mutual, we have this metadata around anything that we deploy, and we organize that metadata in a certain way. So at Liberty Mutual, we have these things called business units, which are really at a high level just our personal and commercial lines business. And then within those business units, we have an idea of called an organization, or really a team. And those organizations could be anything that the business units want them to be. They could be a 4 or 5 person agile team. They could be a group of teams that are working on similar products. It can really be anything they want. And so we use that metadata to create artifacts. And those artifacts are things like Git repos and build deploy pipelines. And those Git repos and build deploy pipelines are used to deploy deployables. And those deployables are really anything that can be deployed through the pipeline. So it could be a encryption key, it could be a MongoDB Atlas cluster, really anything that we deploy. So all of our deployments have that metadata associated with them. Well, in Atlas, they do things a little bit different. They don't get as granular as we get, don't have as many levels of metadata. And so what I think Atlas wants you to do is they want you to create an organization, and that organization is really at the business unit level in our mind. And then within that organization, you have projects, which I think would be more at the artifact level. And then within that project, you can have multiple clusters, which feels like a deployable. However, that doesn't match up too well because they have lots of users and settings at the project level that we may want to have different than from our dev and test and production environments. And so we really want to be able to control all of that at the deployable level. And so we are going to stick with the organizations at the business unit level, but instead of having the projects at the artifact level, we're actually going to put the projects and the clusters at the deployable level, because we are actually deploying the project at that level, and it gives us the opportunity to do some things to our dev environments that we don't typically do to our prod environments. So let's talk a little bit about what we're going to be doing and lay out the map of what this demo is going to be, and then we'll kind of guide you through it. So the first thing we're going to do is we're going to create the project, but to do that we need a master API key for the organization so that it has that level of access. But we don't want to give that out to everybody. So what we're going to do is we're going to create the project with that organization ID, and then we're going to create an API key just for that project. We're then going to delete some of the default alerts that come out with the project, and I'll explain a little bit more about why later. Once that's done, we're going to create a KMS key in our AWS account, along with an IAM user with access to that KMS key. We have some logic that will rotate the IAM user credentials every time we deploy our project. All right, now we're back into Atlas. So we're going to take the API key that was created for our project, and we're going to configure encryption, auditing, alerting, create our cluster, configure our maintenance window, configure our backup schedule. That's all done mostly with Terraform. And then we're going to create our private link, and you can see there's some back and forth between our Atlas account and our AWS account to do that. All right, let's hop in and start doing some work. So this is Liberty Mutual's console for our dev community. And we're just going to go in here and create the artifact like I talked about earlier. And we're going to use our AWS tile to do that. But first we have to figure out what we're going to name our project. And I'm going to have a little bit of fun here with one of our salespeople. Tony loves Villanova, and he loves to tell people that he went to Villanova. And so every time we see him, we kind of give him a little bit of a joke about it. And so we're going to name our project that Tony went to Villanova. We're going to create put it in our organization that I'm a part of, put it against the true application to align it to, and pick our pipeline template. All right, and then we need to create an environment for it. So we're going to put it in our sandbox account in US East 1. It's creating. Just takes a few seconds. Okay, so you can see we have a Git repo now with a link to it, and a build and deploy pipeline, and some other things that we do internally at Liberty Mutual. So let's jump into our code. So I've cloned it down already, and just to kind of show you what's in it, we have a properties file with a few parameters. We're going to grow these as we grow the automation. And here's our Terraform script where we store our state file on S3, and we have our public and private keys variables that feed into our Atlas provider. We have our KMS information, so we can feed that into the KMS section. And we have our cluster name and all the things you need to create a project or a cluster within the Atlas provider. And you can see where I'm using them down here and specifying that information. All right, now let's hop into the Atlas console. This is one, just kind of showing you real quick, this is one of the things that came out recently, was the ability to use our Microsoft AD provider with our Liberty Mutual domain, so that we don't have to have our authentication as part of the Mongo console. So obviously if one of us left the company and had more rights than we should in the Mongo console, we want to be able to control that from an Active Directory standpoint, instead of having to remember that we need to go in here and revoke the credentials in the Atlas console. So that's awesome. Great progress there. As you can see, we don't have our Tony Went to Villanova project out here, so we're not doing smoke and mirrors. This is a live pre-recorded demo, if that's possible. So just a reminder, this is what we're about to do. We're going to take a master API key that has access to our organization, and we're going to create the project, create an API key for that project, and delete some alerts. So let's kick off the deployment. So immediately in the logs, you can see that we run some REST API commands to create the project and create the API key and delete those alerts, and they were that fast, and we're already into the next step. So let's go hop out onto the console real quick and show you the progress we've made so far. We now have a project called Tony Went to Villanova Sandbox. We don't have any clusters in it. We haven't done our private endpoint yet, so we're just kind of showing you we've got a pretty vanilla project out here. Doesn't have anything configured in the advanced section. You can see we have an org API key, and then when we have an API key that we've created just for the project, that's the project owner. You can see we deleted all our alert settings. We don't have auditing set up yet. All right. So our next step is creating the AWS KMS key, the IAM user, and rotating its credentials every time. And so you could see at the end of that log that it was starting to create a CloudFormation template. And if we hop into the Liberty Mutual AWS account and the CloudFormation service, you can see that we're doing all the things necessary to create those resources. And this is a log file just going through that process. And here you can see it's creating the encryption key. All right, now that we have our KMS key and IAM user created, we're off on to the next section where we configure all of our security for our project, along with creating our cluster and our maintenance window and backup schedule. All of that is being done with Terraform right now. All of that, most of that has been features that have been delivered in the last year. So really excited about that. Okay, let's hop back in the logs and see where we're at. Great, we've started the Terraform script, which you can see we initialize our backend that holds our state file in S3. So the next time we run, we know where we left off. And you can see that we're using the Terraform provider. We're creating all the alert configurations. The alert configurations are being created to send alerts to the appropriate team, which is great. And it looks like we configured our backup window and maintenance windows, and we're creating our cluster now. So let's hop back in to the Atlas console and see what's happening. All right, you can see that our encryption at rest has been configured. Our database auditing has been configured. That's all great. What else is going on? Let's see. Okay, we can see our alerts. So you can see that the alerts are now going to an email address at Liberty Mutual that is appropriate. You can see we created a database user. It's not typically the way we're going to do it, but just wanted to show you that you could do it. And our cluster is still creating. So with the magic of pre-recorded demos, I'm going to speed it up a little bit and fast forward the process. Typically takes about, 5 to 7 minutes to create the clusters, just from what I noticed. All right, so we have a cluster, 3-node cluster. You can see our backup policy is not the default. It is more in line with what we do at Liberty Mutual. You can see that we have a preferred maintenance window now. All right, so we're really marching toward the end of this. The next little bit complicated part is the private link setup. So with the private link setup, we have a little bit of back and forth between Mongo and AWS. We have to initiate the creation of the private link service with AWS. We have to then take that service name and create the VPC endpoint in AWS, and then we have to go back to Atlas and verify that endpoint. So you can see in the logs, we've already started the process with some REST calls. We'll go hop into the Atlas console and see what's going on. You can see that that process has started. The REST call is asynchronous. So in our script, we continue to loop through to see if that private endpoint has been created or not. So as we're waiting, I've kind of created a little graphic on here to kind of show you what's going on. So you can see that Mongo is created the private link endpoint, and we've got a cluster created. Behind the scenes, that's in AWS, and the service name is also in AWS. It takes 3, 4, 5 minutes for this endpoint to get created. Okay, so you can see that the service was created, and we are going to take that service name and use it to create a VPC endpoint in our Liberty Mutual account and point it to that service name. We're also going to attach a security group to the VPC endpoint to allow access to the endpoint. Okay, so one more last trip back into the logs so we can see the progress, and the endpoint is being created in the Liberty Mutual account. I'll show it to you on the CloudFormation screen and the events that are happening with the stack. And it's just about done. You can see here the progress we're making. And the template is done. And now we have to verify that the endpoint is ready. So you can see that we've changed to pending now that the endpoint got created in our AWS account. And we're looping through waiting for that endpoint to become available. So that should be done here shortly. You can, once the endpoint is verified, we're going to connect our application to it. But we're going to flip over and see every developer's favorite color, green, and see we have completed our successful deployment. All right, so that concludes the official demo. However, there was one piece that we didn't have fully automated in our pipelines yet that I wanted to cover, and that's the MongoDB Atlas secrets engine with HashiCorp Vault. And the value that HashiCorp Vault provides is the ability to create dynamic secrets. And what that means is I'm able to create a user ID and password with a specific role and a time to live on it. So I could allow a developer to gain access to a database for minutes, hours, or days, months, whatever we deem appropriate, just by issuing some commands with Vault. We also use it to create IDs and passwords for our applications to use, which is pretty cool. So the first thing is you have to let Vault know about your Atlas project. And I just want to be clear in that MongoDB Atlas, the way you create users is different than you create users in a MongoDB database. Typical MongoDB database, you would connect to the database with an ID that has access to create credentials, and that ID would create an ID and password with a certain role or a certain level of permissions, and that's the way you do it. In Atlas, the way you do it is you create the ID at the project level, and you do that with API commands, not MongoDB commands. So when you configure Vault to know about your Mongo Atlas database, you provided the project ID and the API credentials that have access to create those IDs. You then run another Vault command to create the roles that are available or that you want to be available for that database. And examples of that could be read write, read only, admin authority, things like that. And then you retrieve those credentials based on those roles. So when you would retrieve a credential for read write for your Mongo Atlas project, it would return you an ID and a password for a certain time to live. So just want to kind of run down that. It's an amazing technology. We love it. We're really excited that MongoDB Atlas partnered with HashiCorp to provide that this year. It's really exciting. Okay, so I think that's it. Brian P., take it away.
Thank you for watching the demo. And here are a couple of items that we still have left to talk about. Single sign-on, or SSO, was not discussed in this presentation as we are still testing out its capabilities. We felt it a little too premature to introduce as a fully integrated feature. Again, we've implemented single sign-on at Liberty Mutual with Atlas and can report that it is operating well. However, one thing that we've asked Mongo in regards to SSO is the ability to provide role-based access based on Active Directory group membership. This will allow us to dynamically give our developers correctly scoped access to their projects in the MongoDB Atlas console. We hope to be able to provide an update soon. Another item in the crystal ball is Atlas account management. As of this moment, this feature should be available. However, it is not at the time of preparing this presentation. One big ask that we've had from Mongo is the ability to manage our own credits within our own organizations. We feel that this will help streamline the chargeback to our customers and make the billing statement less cumbersome. Envisioned is a master payer account, effectively one account to rule them all. Thank you for attending our presentation. And we'd like to put a shout out to all the people from MongoDB that have helped us out, from our enterprise sales team to the enterprise support and professional services teams. Enjoy the rest of your MongoDB live event, and please feel free to join us on our town hall hours on Wednesday from 10 to 11 Eastern Standard Time. Thank you.